No, because our decimal home is back here, so we're talking about a pretty large number. Here, so our exponents are actually
Just getting your papers.
because we're going from this is a small number. It's really 1.7 something. So we want to have positive exponents represent big numbers.
Riley.
I like it, Riley.
Well, that was fast.
Okay, perfect. Next, guys, next two. We need to, and we need to. Number 4, yeah. Leave your workbook at your desk there. Yeah. Kendra's got number 5.
I wanted number 5.
Tom cast the wrong answer.
Wanted to read positive.
Oh, number 3. Oh, I thought you were talking about number 2 on this one. I thought that's what you were talking about. So this one is going to be positive because it's a big number. This one is going to be negative because it's a small number. Or moves to the left. That's where our negative numbers are at.
That means I insist my way.
I thought you were talking about that.
That's very interesting.
So let's see which one. So, okay, number 4. So we're quick to give a hand, right?
Yeah.
Are we quick to ask questions and see if it's the same thing that we have?
No.
Yeah, go ahead, Jenna.
Isn't it supposed to be a negative if it's the decimal before it's put in scientific notation?
Okay, so Deidre, look at them. And that's the conversation me and Cass were having over here, you guys, is, and there was a little, I thought you were talking about this one, but making sure that your large numbers have positive exponents, your small numbers have negative exponents. That's one of the things that we need to be focusing on. All right, Kendra, get this last one done and move on. Yeah, Cass, go ahead. Get your password. Now, forgot the negative, but that's the difference is if it were a positive, then we'd be talking about a pretty large amount, right? All right.
No, he tried to break it.
I tried to break it, but
He tried to break it with the background. He couldn't do it.
yeah.
Wait.
The country put in your mouth.
Oh, can you?
All right, let's take a look at Kendra's up here, please. Ladies and gentlemen. Jaden, can you help Kendra out with her mistake? Just help her out from your seat. So what you might do is look at your own work there and see if you did something different and go from there.
Wouldn't it be 2.5032?
We need, yeah, we need all those digits out there, Kendra, not just the 2, but all of those significant digits that are on that problem, all of those ones need to be, not necessarily those zeros on the end there, Kendra. Just up to those zeros. Now go, there you go. So you see that on there, Kendra? Guys, we're good. All right? I appreciate your enthusiasm for your classmates' work, but we're killing time with that, okay? So, on there, and I noticed this type of mistake as I was looking at students' work, where you're just going out to that front digit and you're not going all the way through. Okay? So make sure that you're including all of these significant digits on these numbers and working with them. Okay? Alright. Student workbooks, we left off on page 46. Yeah, go ahead, Avery. Okay, let's work through all the problems in the lesson, and then hopefully those will get us to a point where we can work through those, okay? So, 46, 47. Okay, I'm gonna go ahead and give you guys, 5 minutes to work through B and C on your own, and this is another one where I'm okay if you do it incorrectly, but I'm not okay if you don't do it at all.
I'm already done with B and C.
You done with B and C?
Yeah, you got for your homework.
Oh, for our homework yesterday?
Yeah, it was.
Okay.
No.
Perfect.
No, I finished everything especially it was homework.
Yeah, that's how it is.
Yeah, if we didn't finish it,
Not right now, we're short on time. Okay? But I will use, since the Promethean board's not working, I'm gonna have to use, I'll use yours, Diedrich. And double check what you do have, okay? So I'll go ahead and get these put up there, because you were right, Riley. I asked you guys to do B and C so we could talk about those real quick. So we'll talk about those real quick. They should be completed already. If they're not, then what could you be doing while I'm sitting here talking? You should be working on them, getting a couple steps ahead of me so that you can, so that when we go through them, if you have questions, you can ask them. If you're good, you're good. Yeah, go ahead, Tevin. Did you have a question?
Not mine.
Okay. Okay, letter B is asking us, what is the sum of the debt for the least three populous states? Express your answer in scientific notation. So, does everybody agree my least populated states are up here? We have 4 billion, 4 billion, 2 billion. How many billions is that? That, to me, that would be mental math.
10 billions.
10 billion. And let me know if you can't see that.
Can I turn off the light?
Sure, that'd be fine. Okay, so we have 10 billion, but it asks us to express your answer in scientific notation. So, somebody that I haven't heard from already, we had numerous examples to work through. What would this be in scientific notation? Go ahead, Jen. 1 times 10 to the 10th power.
I agree.
Now, is that any different than if the student were to go this route here, Jet? 1.0 times 10 to the 10th power? It wouldn't be any different, right?
I did that, yeah.
Could it be, wait, oh, never mind.
10 to the 9th power, so good question. So 10 to the 9th, that would just be these zeros over here, right?
10 times.
And so we always, when we're working with the scientific notation, you want to make sure that you're not just paying attention to the zeros that are on the back end, you're paying attention to the place value, the decimal moving across here. So if we look where this first part right here, so up there, this piece needs to be between 1 and 10. It could be 1, but it can't be 10, okay? So if my decimal is between these two right here, yeah, you with me there, Hannah? Then I'm going to count how many places that decimal had to move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to get it back here. Okay, so we want to make sure that we're paying close attention to that decimal moving. All right, letter C. Carlos, what did you do for letter C? So let's ask. Oh, you did? Okay, so let's work through it together. How much larger is the combined debt of the three?
They're not on C.
Of the three most populous states and the three most populous states? Express your answer in scientific notation.
Where'd you put, like, the scientific notation that we got for the first answer, which is A, and then the second answer, which is B?
And what's our operation when it's asking how much larger is the combined debts?
So Subtraction?
Subtraction, so exactly. So we've identified the operation we're going to use, and you told me what we need to do. Now let's take a look at that. So, Diedrich, I'm having a rough time reading your handwriting here, but is this 1.02 times 10 to the 12th power?
Yeah.
Okay. And that's my answer from A, and we're going to take this one from B. Is that what you're telling me, Carlos?
Yes.
The answer from B, so. Now, here's one thing I wanted that we need to be paying attention to. So we have it in scientific notation here. I can't just subtract these things unless my exponents are the same. If they have the same magnitude or the same degree up here, that's what we need to do. So I want to make them both 10 to the 12th. So if I want this exponent to increase, what direction is my decimal going to move? To the left or to the right? It's going to move to the left. How many places here, Cass? 2 places. Okay, so this is the same thing as 1.02 times 10 to the 12th minus, now Cass, you told me 2 places, right? So that's going to become 0.01 times 10 to the 12th. Now that I have, and this is kind of like getting a common denominator with fractions, but we're getting a common exponent with the scientific notation. So now that we have this, now we can go ahead and subtract. 1.02 minus 0.01 times 10 to the 12th. Now I want, you guys need to carry this out right here. What's 1.01 minus 0.1? What did you get there, Zach? I'm wanting you to do this piece right here. Everybody, not just Zach, not just the people that usually do things, but I need everybody to do that. Look at it as $1.02 minus 1 cent. Isn't that the same type of thing, but I don't have dollar signs on there?
Correct.
What did you got for me? What do you have for me, Zach? All right. So guys, here's what I need you to do. So instead of working through the